Meet Claude Agent Go, a Go SDK for building agents on top of the Claude Code CLI. It's the Go counterpart to Anthropic's Python Agent SDK. The idea is simple. The CLI already knows how to be an agent. It runs the loop, calls tools, manages context. This SDK drives that binary from Go and hands you a clean type surface over everything it can do. Over the next few minutes, we'll go from a one-line install to running your first agent to in-process tools, permissions, hooks, and subagents. And every feature you see is backed by a test against the real binary. Let's get into it. Start with the mental model because it explains everything else. Claude Agent Go does not re-implement the agent loop. That lives inside the Claude binary, and that's deliberate. The SDK has exactly 3 jobs. It builds the command line from your config. It streams your prompt to the process over standard input, and it parses the output back into typed Go structs, sessions, cost in dollars, token counts, and content blocks, so you never touch a raw line of JSON. Because it's a thin client and not a re-implementation, it has 0 external runtime dependencies, apart from the official MCP library used by a single package. That's the whole shape of it. Your Go code on one side, the binary on the other, one pipe in between. Getting started takes a single command. Go get github.com/teggo/Claude Agent Go. There are only 2 prerequisites. You need the Claude CLI installed and on your path. That's the binary the SDK drives. And you need valid credentials, either an Anthropic API key or a logged-in Claude subscription. Once those are in place, you're ready to write Go. No services to stand up, no daemon to run. Here's your first run. You create a runner, choose a model, and call run.json with a prompt. What comes back is a fully typed result. The assistant's text, the session ID, you can resume later, the total cost of the call in dollars, and the number of agentic turns it took. That's 3 lines of Go to run a real agent. There are 2 more entry points alongside it. Run gives you plain text when that's all you need. And RunStream gives you a live feed of events as they happen, which is exactly where we're going next. For anything long-running, RunStream is the one you want. You pass a progress callback, and it fires for every event the CLI emits. The assistant thinking, each tool call, and the final result. This is where you drive a progress bar in a UI, or emit a heartbeat so an outer timeout, a request deadline, a job runner, doesn't kill a healthy long task. And if you turn on partial messages, the callback also receives token-by-token text deltas, so you can render the answer as it's being written, the same way the chat interface does. The whole process group is cleaned up for you on cancel or timeout, so nothing is left orphaned. Now, the headline feature, in-process tools. This is how you give the agent abilities that are specific to your application. You hand it your own Go functions, and it calls them mid-run. There's no separate server to write, deploy, or authenticate. You define a tool with a name, a description, and a handler function. Under the hood, the SDK stands up a tiny local server. The real Claude binary connects back to it, and when the model decides it needs your tool, your Go code runs and its result flows back into the conversation. If you'd rather not deal with raw JSON, use register instead. You pass a typed Go function, and the input schema is inferred straight from your struct, validated before your handler ever runs. Sometimes you don't want a one-shot call. You want a conversation. That's the client package. It keeps a single Claude process alive across many turns over one bidirectional connection. Ask it to remember something on turn 1, and it still knows it on turn 2 because it's the same session with full memory. No replaying the history yourself. On top of multi-turn, you get token-level streaming per turn and a real interrupt. You can stop the model mid-thought, and it waits for an acknowledgement before the turn ends so your state stays consistent. This is the foundation for everything in the next 3 sections. Here's where it gets powerful. With a can-use tool callback, you decide, in Go, whether each individual tool call is allowed to proceed. While the agent is paused, waiting, your function runs with the tool's name and arguments, and you return allow, or you return deny with a reason the model can read. And this isn't advisory. A deny actually blocks the call. The file never gets written. The command never runs. We don't just claim that. There's an integration test that denies a write against the real binary and then checks that the file genuinely doesn't exist. It's your policy enforced in your own code at the exact moment it matters. Hooks give you that same level of control, but at the lifecycle level rather than per permission. You register a pre-tool use hook, and your Go function runs right before a matching tool fires. From there, you have three moves. You can observe the call for logging or auditing, you can rewrite its input before it executes, or you can block it outright with a structured reason the model sees and reacts to. It's policy enforcement and instrumentation, written in plain Go, with the full type safety you'd expect. And like everything else, it's verified end-to-end against the real binary. You can even define subagents directly from Go with no files on disk. You give one a description, a system prompt, the tools it's allowed, and a model, and the main agent can delegate work to it through the task tool. This is the clean way to build multi-agent systems where the team of specialists is defined in code and version controlled alongside it, instead of scattered across markdown files. Want a dedicated security reviewer or a focused test writer? Declare it inline, and the orchestrator can hand off to it on demand. One last thing, and it's the point of the whole project. Everything you've just seen is backed by integration tests that assert behavior against the real Claude binary, 17 of them, on top of more than 90% unit coverage across every package. So when the docs say a deny blocks a tool or a subagent actually runs, those aren't claims you take on faith. They're tests you can rerun yourself. That's Claude Agent Go, typed, dependency light, and built for real agents, not demos. Start on GitHub, run Go Get, and go build something. Thanks for watching.